Hello, welcome to my tutorial on how to do ionic compounds without polyatomic ions, how to do ionic compounds with polyatomic ions, and how to name molecules. So, to start us off, we're going to do sodium sulfide. This is my first example here. But first we're going to look at our periodic table. So, it looks like a normal periodic table except for the transition metals are back there, but that doesn't really matter right now. So, what first we're going to look at is the numbers at the top of the periodic table up here. Those are oxidation numbers. Oxidation numbers are the number of electrons the atom's trying to gain or lose. So, starts off sodium, Na. It's 1 plus. So we just write that down as the first thing we have to do. And then we have sulfide. Sulfide is sulfur. Now when writing these, it has the second letter back here, the negative, has a "ide" at the end of it. So we're going to write S and then 2 minus. So there are two different ways to write this. This isn't our complete thing right here. We're going to first do something else. So first I'm going to show you the chart method. So to do the chart method, you draw two little lines. You put both oxidation numbers at the top right here. You don't have to do the negatives or the positive. Just 1 and 2. And then you put the least common multiple of the two numbers at the bottom. So that would both be 2. In the middle right here, you write what the number has to be multiplied to get to 2. So for 1, it'd be 2, and 2, it'd be 1. So those are where our subscripts. So what we're going to do is we're going to take N, A, and then we're going to put 2 at the bottom of it right there. That's what we have to do. And then we just have to do S. And we don't have to put the 1, just has to be S. So that's our final answer for sodium sulfide. So now we're going to move on to lithium oxide. So lithium is Li, and it's 1 plus. So first we're going to then get oxygen, or oxide. So it's right there. So O2 minus again. So there's another method to doing this. It's a lot faster. Sometimes it doesn't work. Most of the time it works. I'll let you know how it doesn't work. So first, how you do it is just move those right there. Li, O2. No, wait, sorry. Did that wrong. Meant to do Li2, O1. That's all you have to do. That's easy, fast. It's basically this up here, but faster. So you just move it over. I mean, if you can also do it again, it's basically the same thing we did over with sodium sulfide. We just basically switched the numbers. So now we're going to move on to boron. Or first I was going to tell you how this over here doesn't work. So if it was, say the oxidation numbers were 2 plus and 2 minus, they would both be 1. So that's because they cancel out, so they just make 1. I mean, if you do it the other way too, the least common multiple is 1, so the only way to get for 2's to get to 1 is 1, so that would be your answer for that one. But we're going to erase this now, and so now we're going to move on to boron sulfide. So in boron sulfide, so we have B, and then so boron's right there, so it's a 3 plus this time. And then we have sulfide again, so S2 minus. So it's getting a little crowded in here, but if you can see, we're going to just do the crisscross method. So it'd be B2 S3. And that would be our answer for boron sulfide. I mean, yeah, it helps to check your work if you're doing this on a test or something, just to make sure it's correct. But that's basically all there is to this. So now we're moving on to polyatomic ions. So polyatomic ions, they're basically two atoms together. So I have a little chart up here for polyatomic ions. So we have like borate, sulfate, nitrite, and etc. This is not all of them. There's still others that are not listed up here. But one of the things about polyatomic ions, they're always negative except for ammonium. That's a special one. It's plus. So we're going to start this off with doing the potassium hydroxide. So potassium is K. K is 1 plus. So, oops. 1 plus. And then we have hydroxide. So hydroxide is up here with, it's OH 1 minus. So AOH 1 minus. So that's not it. We could do what we did earlier with the switching up the ions and everything. So I'm just going to move this over to the side a little bit. So you can write our final answer, which is going to be KOH. So now we're moving on to lithium nitrate. So Li is lithium, and its oxidation number is 1 plus. And then we have nitrate, so which is N. Wait, no, sorry. NO 1 minus 3 down there. Okay, so then it's kind of the same thing again. Actually, no. Yeah, same thing. LiNO3. Now, the 3 stays there this time because the 3 is down here in the corner. And if it's down there in the corner in the beginning, that's how many atoms of oxygen there is. So that's going to stay there no matter what. So that's it right there. And I can show you an example of what happens when oxidation number needs to go there. So in ammonium carbonate, we're going to do NH 1 plus, and then a 4 right there. And then carbonate, which is CO 2 minus, and then a 3 right there. So I should make that back big. But what we're going to do is we're going to do a parentheses. So 2 is going to go over here to the NH over here. So it's going to be right around here. So what we're going to do, instead, since the 4 still has to be there, we put the parentheses NH. Let me move this over. Not like that. But, erase a little bit of this. Oh. Okay, so, hold on. I'll write the answer up here. NH4. It stays in the parentheses, and then we put the 2 on the outside. And then we do CO3. And that's our answer. We have to put the parentheses for that to work. And then, there you go. So now on to molecules. So you have to memorize the prefixes over here in this chart to understand a little bit. So pentanitride is nitride plus 5 atoms. So it'd be something like N4. That's all it is. N4, or no, 4. N5. So peta part of it right here is 5, so N4, 5. And then oxygen, O, and then tri, 3. And that's all it is. All you have to know is the beginning part of each of these. So now we're going to move on to trinitride, which is just going to be N3 again, and then dioxygen, which is O2. It's that easy. All I have to do is just remember the prefix. Remember the prefix, remember the prefix. Moving on down here, the P for phosphide, and hepta is 7. And mono is just 1. So you just write the letter. So it'd be P7O, because mono is 1. So that's really all it is on this slide, and that's all you need to know for this video. I hope you enjoyed. If I did anything wrong, just leave it down in the comments, let me know. So, thank you.